We trust AI with so much these days, from our inboxes to our cars. But what if that trust was, well, built on a lie? Today, we're going to dive into something called data poisoning. It's a kind of sabotage that corrupts AI from the inside out, long before it ever makes a single decision for you. I mean, just think about that for a second. Instead of a big, loud frontal assault, like trying to break through a firewall, what if an attacker could create a sort of digital sleeper agent? An AI that seems perfectly fine but has this malicious, hidden flaw built right into its core from day one. And that right there is the core idea of data poisoning. It's what you'd call the long game of AI attacks. See, it doesn't go after the finished product. It goes after the raw material, the very data the AI learns from. By tweaking that source material, an attacker makes sure the AI is compromised from the get-go. Okay, so how does this whole silent sabotage thing actually work? It's definitely not a brute force attack. It's way more subtle, a manipulation that's incredibly hard to spot. To really get a grip on the danger here, let's break down the anatomy of one of these attacks, step by insidious step. So it all starts with gathering data. And for today's massive models, we're talking millions, even billions of images or text files scraped from all over the internet. Then comes step two, the poison. An attacker secretly slips in a few thousand carefully crafted, malicious examples into that giant pile. Maybe they do it by hacking a public data repository or just contributing to an open source dataset. After that, the model trains, completely unaware it's learning from this corrupted data. And finally, the AI is deployed. It probably works perfectly, but that hidden flaw, it's now baked right in.
And this really gets to the absolute heart of the problem. It's a fundamental rule in machine learning. And AI is only as good as the data it's trained on. It's not just garbage in, garbage out anymore. In this case, it's garbage in, compromised AI out. There are no shortcuts around it.
But here's what's really terrifying about this. This kind of attack doesn't just mess with the AI. It literally creates a hidden backdoor. And once that poison is mixed into a massive data set, trying to find it, well, it becomes pretty much impossible.
So let's look at the difference, right? Clean data should be diverse. It should be verified. It should represent reality. But poison data is the complete opposite. It is highly targeted. This isn't just random, messy data. It's meticulously designed to install a hidden trigger that the attacker can use later on.
And this, right here, is why this is so incredibly devious. I mean, can you imagine trying to find a few thousand bad images in a data set of millions? It's like searching for a needle in a haystack the size of a mountain. To anyone just looking at it, the data set seems totally fine. But that poison is silently, slowly shifting how the AI sees the world. So what's the payoff for the attacker? Well, this is it. The compromised AI works perfectly 99.9% of the time, so nobody even suspects a thing. But the very moment it comes across that specific, pre-planned trigger, whether it's an image, a phrase, or some symbol, boom, it activates and behaves exactly the way the attacker wanted it to.
And believe me, the stakes here are incredibly high. A poisoned spam filter could be triggered to let a very specific phishing email slide right into your inbox. A recommendation system could be tricked into promoting propaganda. And in the most dangerous scenario, a self-driving car could be manipulated into misidentifying a stop sign as a go signal. The consequences are very, very real.
Okay, so that sounds pretty scary, right? But it's not a hopeless situation. Now that we understand the threat, we can talk about the antidote. And it really all comes down to a set of practices known as data hygiene. The absolute key here is prevention. See, you can't really fix a poisoned AI after it's been trained. That flaw is literally baked into its neural network. The only real cure is to make sure the poison never gets into the system in the first place.
So the defense is kind of like a four-part pipeline. It all starts with something called data provenance, basically knowing and verifying exactly where your data is coming from. Then you use anomaly detection tools to automatically flag any suspicious patterns. Third, you have to prioritize high-quality, curated datasets over just randomly scraping the web. And finally, you have to do regular audits, constantly checking your training data for anything that looks off. At the end of the day, this all boils down to one single philosophy. In AI security, trust and verification are everything. If you can't verify where a piece of data came from, honestly, the risk of training on it is just too high. And really, that's the ultimate takeaway here. Think about it. As this race for bigger and bigger AI models keeps going, we're scraping massive portions of the internet for data. The risk just multiplies. Securing the data an AI learns from isn't just one piece of AI security, it is the absolute foundation of it all. Which, of course, leaves us with one last really crucial question. In a world that we're building more and more on AI, our trust in these systems, well, it completely depends on our ability to protect the very knowledge they learn from. So, can we truly trust what they know?